going to overlap with the same example we were finishing with about the tide, and we're going to take that a little bit further today, okay? So let me just give that to you again in case you still don't have that in your notes. H equals 3, forget to do, I don't remember, it won't matter, 3.4 cosine pi sixths parentheses t minus 9 parentheses plus 5. Okay. I did recommend last week that when you're dealing with real-world problems like this, it's best not to draw them on a fixed scale on graph paper. It's actually best to freehand draw this. Okay, so this is the tide. Okay, you've all been to the beach. You know that the tide comes in and the tide goes back out, and that is forming a sine rhythm, okay, a wave rhythm, as something gets higher and lower and higher and lower and higher and lower. And so we want to draw one wave of this and see what we can learn, not trying to force it onto graph paper, but just drawing it freehand. All right, so this is a cosine wave, and so I just want you to draw one cosine wave. Okay, so the top of the cosine would be about here, and then the arrows show, and the bottom would be down here. So rather than try and force this onto graph paper, if we freehand it, and then we can kind of label our scales without having to worry about trying to squeeze it onto a piece of graph paper. So I'm going to put my scale here. And what do I know about the highs and the lows of this graph? Okay, what is the high? Let's not worry about that first. Let's just get our scale labeled first. We are going to move it up, but let's not go a little too quickly. Okay, what's the high right now? Okay, so let's label this 3.4 and negative 3.4. And so the range is negative 3.4 to positive 3.4. Okay, now what we did not get to finish doing last week was labeling the period, the scale across. And so again, we're not trying to force this onto graph paper. Okay, we'll just kind of do that, and let's label what our scale would be that way. All right, so we'll put 0 there, and then we want to figure out our period. So we'll do a little math on the side, and we'll figure out that our period is 2 pi divided by what number right now? Say it again. Pi sixths. Okay, we want to divide it by the value of pi sixths. So 2 pi divided by pi sixths. Now the math on that, when you divide fractions, is always to multiply by the reciprocal. And so it'll be 2 pi times 6 over pi. And what happens there is the pi values reduce each other, and all you're left with is the number 12, which means your cycle is labeled 0 to 12. For the cycle of the tide to be 0 to 12 means 12 hours. Okay? Every 12 hours, the cycle of this tide is changing. And that's about normal. Okay, we know high, low, every 12 hours or so, the tide is going to be going in and coming back out again. So I want you to label your axis as hours here. And then your other axis, I want you to label as meters, because this is the height. All right, now, as Diego was kind of hinting, we are going to change. We're going to move this graph side to side, and we're also going to move this graph up and down. All right, and so Diego had noticed that the plus 5 there is going to result in a shift. Now, I do not have to shift my graph. Okay, this is going to be a trick. We're going to change the scale rather than shifting our graph. So if we're adding 5, we'll be adding 5 to our range like this. And so my new range on the top end would be 8.4, but on the bottom end, when I have negative 3.4 plus 5, okay, when I add those together, I get positive 1.6. And so what you want to do on your meters axis is just change those numbers. You don't have to drag your graph anywhere. Just erase the low and the high value and change it on your scale. So we will have 1.6 and 8.4. And so we have low tide being 1.6 and high tide being 8.4 meters. And if you've ever been out to the pier, okay, either at Seal Beach or Huntington or any of those, you can watch the water come up and down those pylons in terms of the depth, and you can measure the height of the tide that way. All right, now I'm going to ask you the next question. What time is low tide? According to this graph right here, what time is low tide? Okay, so you figured that out because it was halfway. Okay, low tide would be at 6. However, something else, there's one other thing we haven't dealt with in this equation, and what is that? No, we've dealt with the 3.4, we've dealt with the pi 6, we've dealt with the 5. We haven't done anything with the 9. What does this mean? Okay, that means to the right 9. Okay, now I'm not going to drag my whole graph to the right 9. I'm just going to change my scale. Okay, and so I'm going to add 9. And I'm going to add 9. And I'm going to add 9. Which means my scale gets adjusted. And so I have new values for my scale now. Okay, and so my new values are now 9, 21, and 15. So now that changes the answer to your question. The question, what time is low tide? Right? Low tide's not at 9 anymore. What time is low tide?
15.
What does 15 mean? 3 in the afternoon. Okay, 15 is military time, okay, which is 3 hours after. Okay, and so when you answer your questions, you'll answer in terms of AM or PM. We have high tide at 9 a.m. and we have high tide again at 21 hours. 9 p.m. Okay, they're 12 hours separate. Okay, and then we have low tide at 3 p.m. And when would the next low tide be? Yes, 3 a.m. And then it would just continue on that pattern over and over and over and over again. Okay, which is how they can predict when high tides and low tides are going to be. Now, we are not on perfect, you know how we just had leap day, right? What's the point of leap day? Do you know why we have to have a leap day? Why do they add? Yeah, go ahead, Ben.
Like kind of correct the calendar so that the opposite.
Right, because every 4 years, the Earth doesn't go around the sun in exactly 365 days. The Earth goes around the sun in 365.25 days. Well, if we ignored that 0.25 for too long, pretty soon, December would feel like summertime, and July would feel like winter if we ignored it. So we have to do a course correction. For the same thing, tides are not exactly 12 hours. It would be beautiful if they were, but because the Earth is spinning around this sun at 365.25 days, tides are also on a schedule that's not exactly 12. It's like 11.8. All right? And so in real life, the tide charts are not going to be perfect 9 a.m., 9 p.m., 3 a.m. It's going to be like 11.8 hours. And so then pretty soon it'll be 11.8, 11.8, 11.8. And so then that's why high tide's not at the same time of day every day. It's always a little bit sooner, a little bit earlier, a little bit earlier, and it keeps adjusting itself. But when you do a free range, freehand homework problem, I would really encourage you not to worry about messing with sliding the graph. Change the scale, right? Change by adding the numbers onto this or subtracting, and then do it on your X scale too, okay? All right, the next thing we're going to do with real life is learn how to do it on our calculator. So would you get out your calculator and first thing, make sure it's set to radian mode. Okay, radian mode. All right, and I need okay. In addition to the tide going up and down, another thing that we measure that goes up and down is temperature. Now it goes up in the day and down at night, but it also, the average temperature goes up in certain months of the year and down in certain months of the year. So we're going to look at another period of 12. This time it's not going to be 12 hours, it's going to be 12 months. And we're going to look at how this, what the amplitude of the temperature for this is the Albuquerque, New Mexico. Okay? All right, so, and switch this over. Okay, do you remember how to put data into your calculator? Remember what button we do? Anybody? Stat. All right, so you want to hit Stat and Edit. And we're going to do 12 months of data. So go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Those stand for January through December. Okay, those 12 months will affect our window. I want you to remember how we do window. Okay, window has to be lower than the lowest number you put in and higher than the highest number you put in. You usually want to end in 0. So let me set my window for this. Sorry, I'm in a mode for a calculus class. Okay. All right, so what's lower than the lowest number I just put in that also ends in 0? 0, great. What's higher than the highest number I just put in but also ends in 0? 20. All right, so our window will be that. And let's leave it at 1. We could do 2 if we wanted to. That would be counting every 2 months, but 1 month, 2 months, it's okay. All right, now go back to Stat and Edit, and let's add the temperature data, and you can just copy as I go. January was 34, February was 40, March is 47, 55 for April, 64 for May, 74 for June, 79 for July, 76, 69, 57, 44, 35. Does the high temperature surprise you for New Mexico? What was the high? 79. Does that feel, I mean, I always think of New Mexico as being hot, right? But Albuquerque is pretty high elevation, and so it doesn't really get that hot. Okay, so hopefully you got all those numbers. Now we want to finish our window. Our window has to match the lows and highs of this. Okay, so the lowest number we put in was what? 34, and the highest number was 79. And so let's do our low of maybe 30 and our high of 80. And let's count by tens since we're doing temperature. And let's take a look at what this sine wave looks like. All right, so now we've got our data in. Does anybody need the data again? Okay. There's the first 7 months.
I see 9, 6, 12.
Okay, 9, 10, 11, 12. There you go. All right. Then go to your y equals, please, and make sure it's all clear that there's nothing there. and then go to second y equals so we can turn the plot on. Probably all your plots are off. Go ahead and select one and turn it to on. Make sure that it's set as a scatter plot and list 1 and list 2. And once you have that set, okay, you turn your plot on and make sure list 1 and 2 are set, then your graph should show you the first wave of the temperature data. Okay, so can I just come and look at your waves to see if they all turn out okay? Error, what error? Window. Okay, so this is your window is wrong. Yeah, you didn't change any of your numbers like we did. It should be 0 to 20. Should be a low 30 to 80. Yep. Can you just flip it around? It's easier for me to look at. Oh, so you don't have the data yet? You're not getting the data? Okay, so what we would like to do is figure out, have the calculator tell us what the amplitude and the period are. Okay, this is called running a regression. We did that in first semester, so now we're going to run a regression. So go to Stat, not Edit anymore, but what? Calc. And remember we learned all these, we did lin reg, quad reg, we did all these regs. Way down at the bottom is a sine reg. Okay, so pick sine reg, and then don't forget, don't skip over, you got to put your vars in there, otherwise it won't make a graph. So it should be sine reg, list 1, list 2, you can skip the period, but the store reg equation, use your vars and your y vars to put in y1. You will not get a graph if you don't do that step. Okay, so make sure that you put that little step in. Then go to calculate, and it will calculate the period for you and the amplitude for you and any shifts that were there. So it's calculating it. A tells me the amplitude. B is the B that I use to figure out the period. So you actually still have to do 2 pi divided by B to figure out the period. Your C and your D are your shifts. So it gives you all the information that you need. And then when you hit graph, you should see a really nice sign that's going to keep going beyond the original data. Is anybody not getting that? Not working? Oh, you need list 1. Okay, see it's in blue right there? I know. So change it. Use your blue key. There, so that's it. And then put in the bottom. Yep. Okay. All right. So now, can you tell me what the temperature would be the next February? Okay, what was the original February? What number did we use? February is what month? 2. Okay, what if we want to know the next February? 14. Okay, let's use 14. So clear out of here and use your vars and put parentheses and tell me the next February, which would be the 14th month. Okay, the temperature is going to be, oops, that's not what I wanted. 14th month. Okay, temperature will be about 37 degrees. How about the next July? Okay, well, if I know the original July was 7, the next July would be 12 months after that, so that would be 19. So if I wanted to do the next July, then I would do 19. About 78 degrees. What was the amplitude? Oh, well, let's look back at that again. Maybe we went too quickly and we didn't write it down. Oops. Oh, I am going too fast. Okay. Okay, what was the amplitude? Double check. I think I went too fast and deleted something. Oh, there we go. Okay. Yeah. All right, 21.789 is the amplitude of this. Okay. The period we can figure out by doing 2 pi divided by 0.526. If we do the math on that, we can figure out the period. We can tell what the shift is, and then what if I wanted to know the range? Okay, to do the range, you have to do the original amplitude plus the shift. So the amplitude is 21, so the original range would be 21.789 to 21.789. But the shift says bump it up 56 degrees. So add 56 to that, 56 point, what is it, 255, and that will tell you the adjusted range of your graph. Okay, so then you would add 21.789 to 56.255, and you'd come up with an adjusted range, which is going to be 78 point something, and then you would add this one to figure out your adjusted range. Okay, so you start with the original amplitude range, and then work on the adjustment based on that. Okay. All right, so that's working with real life. Some you'll do by hand with no calculator, okay, or no graph, just do them by hand, and then some you'll do with your calculator, and have the calculator figure out the amplitude and everything for you. All right? Okay, so then review day tomorrow, and then quiz on that stuff on Thursday. Okay. All right, good start. Okay, one day down out of our 3 weeks. Okay. And my Broadway people, you guys were amazing. Mia and Pedro, and who else? Is that it? Mia and Pedro in here? What? Oh, Michael. Okay. You guys did fantastic. I hope you slept in really long on Saturday. No?
A little bit. Not as long as I hoped to.
Bye.
Thank you.
Welcome. See ya.
There's something called insurance. Pays off. Doesn't matter. Pays off to your parents or your children, whatever. So economically, it's better. It's awful. The final unit. The final unit. Stop the war.
I will be here on Friday because I have a robotics competition.
Okay.
I know. I'll turn in my homework.
What is that?
Yeah, I come in on Thursday.
Yeah, or Monday when you get back. Either way.
I forgot my folder at home, but if you send me a picture of my homework, can I send to you through email?
Yep.
That'd be cool.
Oops.
Credit on Friday. Get on top of it.
But I'm going to take negative extra credit points if you bring Apple. I'm just kidding. I know, but we always end up with so many.
I'll just bring apple, marshmallow.
Let's see.
Not a bad idea.
Okay.
Not a bad idea.
What? Yeah, I'm a single serving pie. Let's see, I'll take the radius and divide it by 10 and then give you that many extra credit points. I don't know, I'm just kidding.
Not a bad idea.
There you go. Sure, bring a pizza, bring a quiche, bring a shepherd's pie, a chicken pot pie. I'm just teasing. I know. Pie Day Friday. Actually, Pie Day Eve. Pie Day Eve. They used to say, people would say, it's pi minus 1. And I had to say, it is not pi minus 1, because pi minus 1 is Valentine's Day. Right? 3.14 minus 1 is 2.14. That is Valentine's Day, pi minus 1. So it is pi minus 100th. It is 313 and not 314. So we will celebrate that Friday. I'll bring all the plates and napkins. You bring a pie of your choosing. Chocolate is usually the favorite, the one that has gone fastest. Okay. Any other creams tend not to be very popular. Banana cream, then it's not very popular, then you'll get to eat it all. Okay. All right. Kudos to all of my Broadway people. Okay. I saw Wednesday's dress rehearsal and then all the performances, so I was impressed. So let's see, Luke and Isaac and Irene, and I listened for the flute in the pit. Let me hear Abby playing. Okay, Liv and Andrew. Is that everybody? Okay, all right, so Broadway 2020 in the books. Yes, it was really so much of a fun one. All right, and so now we're looking at robotics week, right? So just remind me, how many of you will not be here Friday? Oh, you won't be here Friday. Who's in just you? Just you and Holiday. That's it for robotics? Okay. All right. 3 weeks till spring break. Okay. Does it feel long? But then when we come back from spring break, we have 2 4-day weeks in a row. So that's awesome. So can afford it, the 4-day weekend in between. But yeah, we'll be done with AP Calculus stuff on Thursday. That's our last lesson on Thursday. And then next week we'll take our last test, which will leave us a week and a half before spring break to get started on our AP review. And then when we come back from spring break, it'll just be all AP review all the time. And you guys will be ready to go. All right, so let's check out your answers to the those 3-dimensional shapes that, based on your perspective from the bottom or the side, had different perspectives, different profiles. Okay. All right, Holiday, can we start with you in the back with number 1, part A?
I have 4.9348.
Say that again?
4.9348.
They just asked for a formula
Oh, I have
for
a
the
minute ago.
They just asked for a formula for the area. They did not ask for the volume. They
Oh.
only asked for a formula for the area, and that was it.
Squared.
Close, but that is not the, not the, it is pi times some kind of radius squared, but it is not x squared. Okay, all right, Abby, you want to give it a try? There we go. Okay, the semicircle is the square root of 1 minus x squared, and so when you square that, the square root goes away. So pi times 1 minus x squared as a quantity. All right, Terry, part B.
4 times 1 minus x.
Okay, 4 times the quantity 1 minus x squared. And C, Andrew?
I got quantity 2 rad 1 minus x squared over rad 2 squared.
Okay, that is the base, but what about the height? This is a, that's not the area of a square. You found the diameter of the diagonal of the square, but that's not the area of the square. So you got to take it a little bit of a step further. You need to find, once you find the diagonal, then you have to find the base, the value of the legs. It's a 45, 45, 90 triangle, right? If you, I know that the square is turned on its side. Okay, so the square is like this, turned on its side, and it sounds to me like you found part of that maybe, or did you find the leg, is what you were describing? Because, yeah, this corner was 1 minus x squared, and this corner over here was negative 1 minus x squared. All right, so you think maybe you found out the leg?
I think so.
Okay, and what was that again?
Well, I think.
I heard you say something over 2.
Yeah, rad 2.
Okay, so tell me again. It was like square root of 1 minus x squared over rad 2?
Yeah.
Okay. That's the length of the side. What is the area?
Then we need to use that side square rad 3 over 4.
Well, if this is the length of one side,
Yeah.
what's the length of this side? Same. And so what's the area?
Then don't you have to find that height? Oh,
No, it's just a square.
Yeah, so don't you just like square the whole thing?
Okay.
So
Yeah.
yeah, that was my answer.
Well, you had said,
Side square was just that 1 leg square.
oh, well then simplify it.
Oh.
Okay, I mean, okay, I'm getting what, so you're saying 1 minus x squared over the square root of 2, and then you're saying
Yeah,
that
I just-
squared? Okay, we'll simplify that, yeah. I mean, this is a square root, that's a square root, that's a square.
Yeah.
Let's make that a little bit simpler.
So 1
Okay.
minus x squared over 2.
Okay. All right, part D, Stephen.
Rad 3 times the quantity 1 minus x squared.
Okay, those are for equilateral triangles. All right, number 3, Lucas. Yeah.
16.
Okay, 16 cubic units, thank you. All right, Sophia, number 4.
16 over 15 pi.
Okay, thanks. 16/15 pi. Okay, number 5, Stephanie.
16 over 3.
Okay, Jake, number 6.
I got 8 over 3, but I didn't put units.
We don't know the unit, so we just give a generic cubic units.
Okay.
Okay, all right, Gabby, how about 39? Sorry, how many for part A?
Okay, 2 by 3.
Okay, 2 rad 3 cubic units. Andrew, part B.
8 units each.
8. All right, Irene, number 40A. Okay, I might suggest that you consider factoring a pi out of your answer, since there is pi common to both of that. So can you tell me what that would be if you factored out your pi? So pi on the outside. Okay. All right, Isaac, how about number or letter B for the same problem?
4 rad 3 minus 4 pi over 3.
Should just be 2 pi over 3. It shouldn't be 4 pi over 3 for that much of it. Maybe the rest of it is fine. Okay, Jeremiah, number 41.
I got 8 pi units cubed.
Okay, and Adrian, number 42.
I got A over 3.
Okay, very good. All right, now I know all those answers and work and stuff is posted in Slater, so most of you check that before you come to class. Is there anything you still need help with?
I just have a question. Normally when you have like the diagonal of a square, is it always usually divided by rad 2? A lot of the problems have it where it had to be divided by that.
Yeah, so the proportions of a 45-45 triangle. Okay, so a square is based on a right angle with 45 degrees here. Okay, so no matter how long the sides are, we call it the side an arbitrary A. That will also be an arbitrary A. And using Pythagorean theorem, we can figure out how long this is. So it would be A squared plus another A squared equals the diagonal of C squared, which is 2A squared equals C squared. So C, which is the length of the diagonal, would be the square root of 2 times A. So square root of 2 times A. So no matter if this is 3, then this will be 3 times the square root of 2. If this is 10, this will be 10 times the square root of 2. So yes, they're all related to the diagonal is rad 2 multiplied by however long the corners are. That's all based on it being a right triangle and being the Pythagorean theorem. Okay? Yeah?
Do you need 41?
I can. Did you want me to?
Yeah.
Okay. It's hard on those. Okay, so like now you switch. So 39 and 42 in that section had pictures. 40 and 41 don't have pictures. And so your job is to come up with that, I think, right? Yep, to come up with that on your own. Okay. Did you try and draw it? Okay, well let's get a picture of it. Right, so here's our axis, x and y, and it says that the solid is between y equals 0. And y equals 0 is which axis? Okay, and then y equals 2, which is going to run parallel. Ooh, I didn't draw that very well. Okay, and so there's y equals 2, and this is also known as y equals 0. So the space between these all the way across is how much? 2. Yeah, that's pretty consistent, pretty steady. All right. Now, the cross sections perpendicular to the y-axis, which is different than we've done before, are circular discs going between the parabola x equals rad 5 y squared. So let's think about that a minute. X equals rad 5 y squared. Okay. For me, when I draw a parabola, I need to think of it as y equals something, so let me switch that around. So this will be y equals x divided by rad 5 and the plus or minus square root of that. Okay, are we good on that? All right, so what does that look like? Y equals the plus or minus square root. Okay, so it's coming coming from 0 and eventually intersecting there, and then the other one is coming this way. Okay? However, I don't have to worry about this bottom one because the direction said I have to be between here and here. Okay. So I have this base shape. So what would the profile of the base look like to you if you were looking at this from the bottom? A curved triangle, yeah. That's what I would picture too. It would be something like this, this, and then like that. Okay. Now it says running perpendicular to the y-axis are shapes that are, what did they say, circular. Perpendicular to the y-axis, not perpendicular to the x-axis. So I'm not slicing this, slice, 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 slice. I'm not slicing it that way. I am slicing it this way. Okay, so very different than what we had done before. So my slices go from here to here across, and then there's part of the circle that's underneath it. And there's a diameter that goes across. So where is the biggest circle? Like size-wise? Yeah, in the back. So in the back, you'd have your biggest circle going from here to here, and then the bottom of it under like that. Where's your smallest circle going to be? Yeah, at the front, there's these little itty-bitty little baby circles all here. So you've got all these circles. Let me draw maybe one more here going across. All right, so there's my shape. Do you know what, can you picture one of those old record players that had the big funnel? I mean, it's kind of like that, where it's small here and then it's widening out into this wider piece with a big sort of trumpet end on the outside. Okay, we need to, let me pick a random, let me pick this one and this one. Okay, I'd like to know what the ends of those two, that diameter is, so that I can work on figuring out how long the diameter of one of these is. Okay, so this coordinate point right here has what for an x value? 0. Okay, and we don't know the y value, we'll call it a. All right, so directly across from that, what will it have the same as the other one? We'll have a as its y value. What will its x value be? Not y, but what am I using for y right now? Okay, so rad 5 a squared. So how long is it from this point across the diameter to the other point? Okay, so that is called the diameter. So my diameter is rad 5 a squared. But for me to find the area, I don't need the diameter. What do I need? Okay, so what is the radius? Okay, so rad 5 over 2 a squared. All right, and before I can integrate it to find volume, I need to have an expression for the area of that single circle. Okay, so pi. Okay. So clean that up. Pi times. Okay, there we go. That is the equation for area. So that was all geometry. It's a little bit of algebra, knowing how to square root something, and coming up with that's the hard part. Okay? Now the calculus part should not be that hard. It should be setting up an integral. You just take this guy, pi times 5/4 of a squared, or we can switch to y squared dy, because we're going along the y-axis. And what are the bounds as we're going along our y-axis? 0 to 2. Okay, and then you're kind of in the home stretch. I would pull 5/4 pi out since it's a constant and have 0 to 2. and then just have y squared dy, and then do my calculus from there. Antiderivative, plug in, and then you're kind of home free. Okay? But the hardest part is this part right here. Well, maybe the hardest part is drawing it, is understanding it first. For me, I have to have a visual so that I know that this is running sideways along the y-axis, perpendicular to the y-axis, as opposed to, slicing it the other way like we had before. Okay? Yeah.
It needs to be y to the fourth.
You're right. I wrote it correctly right here. All right. So then, if I was finishing this, my antiderivative would be 1/5 y to the 5th plus the constant c going from 0 to 2. So that would be, the 5s would reduce, so 1/4 of pi times 32. So all that to say we just get 8 pi for our answer. Okay, all right. Did you run into any other trouble on the homework? Okay. Great. Okay, can you give those to Adrian? Thanks, Adrian. Okay, we're so close.